Hello everyone and welcome back to our videos. Today we will talk about the induction system on reciprocating engine, chapter 5, section A. The induction system is designed to supply air to an engine to support combustion. On reciprocating engine, air enters an air intake and is routed to a carburetor or another fuel metering device. The air is delivered to the cylinders for combustion. The primary purpose of the induction system in the reciprocating engine to provide air in sufficient quantity to support normal combustion. The air intake of the induction system or reciprocating engine is classified to three types. The classification of the induction system in the reciprocating engine: the first one, normally aspirated, supercharged, or the third one, turbocharged. In the normally aspirated system, air for combustion or an air-fuel mixture is drawn into the engine's cylinders by atmospheric pressure acting against the partial vacuums that occurs as the piston travels downward bottom dead center during the air intake stroke. In reciprocating engine, the dead center is the position of piston in which it's either farthest from or nearest to the crankshaft. The former is known as top dead center. This is the top dead center, while the latter is known as bottom dead center, and this the bottom dead center. The normally aspirated system consists of four basic components. The main components of the normally aspirated engine: A. Air intake, induction filter, fuel delivery system, the last one, induction manifold. The air intake is designed to direct the outside air into the carburetor or other fuel metering device. It's located to take advantages of ram air pressure as much as possible. By taking the advantages of the ram air pressure, the pressure within the intake is typically higher than any other point in normally aspirated induction system. Because of this pressure rise, as well-designed intakes scope can have substantial effect on the engine power output. The second component is the induction filtering. Air filtering used to increase the reliable operation and long serve life of the induction air. So here, to increase the reliable operation and long serve life, the induction air must be free of FOD, foreign object damage. To accomplish this, filters are installed in the air intake duct to prevent dust, sand, abrasive material. The danger of the dust to the human body and aircraft. Dust can be carried into the cylinder by the induction air. Dust particles accelerate wear on cylinder, wall and piston ring, silicone, falling spark plug, and contaminate the oil. The dust contaminate in a fuel meter device. It clog the oil passing and starvation. Filter maintenance. The efficiency of filtration system depends on proper maintenance and service. Proper removal, cleaning, or replacement of filter elements is essential to ensure proper engine performance. The types of air filter: flocked screen, and we called wire screen, paper filter, and polyurethane foam. We will start to talk about the first one, wire screen filter. This filter is filled with reusable material known as flake. Cleaning and service it by washing it in safety solvent. Once clean, soak the element in the engine oil. After the fiber element saturated, suspend the filter and allow the oil to drain. The second filter, paper filter. Like used in automobile, this can be cleaned by blowing air in the opposite direction of the normal airflow. The last filter, polyurethane foam filter. This filter impregnated with glycol solution. The glycol solution make the filter stick so the dust and air stick to the element. To serve this type of filter, the foam element is removed and discarded and a new one is installed. So no clean is recommended. The third component of a separated system is fuel delivery system. The fuel delivery system, it can be either carburetor or fuel injection system. What they are do. The carburetor or fuel injection system used to meter the amount of fuel and air that deliver to the cylinder. The fourth component, intake manifold. It consists of duct that goes from the fuel metering device to the individual cylinder. In horizontal opposite engine, the intake manifold is the connection point of all the individual pipes which deliver fuel air mixture to the cylinder. One end is bolted to the cylinder intake, the other end is attached to the manifold with a short synthetic rubber hose or rubber backing and backing nut. Both methods permit some movement between the intake pipe and the manifold. As the cylinder expands and contracts, in some installation, the intake manifold passes through the oil sump before it branches out to go to the cylinder. The benefit of the oil or the air manifold pass through the oil sump are increase the temperature of the air of the fuel air mixture. The second advantage, better fuel evaporation. These two advantages of the air manifold that will pass to the oil sump before it branch out to go to the cylinder. In the radial engine, the distribution impeller, one important thing of the air intake manifold, it must maintain gas tight seal. If the gas tight doesn't maintain, air will leak into the intake manifold and lean the mixture. This will cause the engine to run rough. Small induction leaks are noticeable at idle because the pressure differential between the manifold and the atmospheric is greatest at low RPM. By the end of this video, I hope you can answer the following question. The induction system consists of these four major components. What are they? The second question, what three types of air filter systems have been used on aircraft? The third question, reciprocating engine induction systems can be broadly classified as some modern horizontally opposed engines that use float carburetors have the carburetor mounted directly to the bottom of the engine. You have to fill this, and the induction pipes pass through the worm. The last question, what are the two advantages of passing the fuel-air mixture through the engine oil sump?